So that class. Okay. I think how much base and how much our factor the change. All right. Some of the things that we can do here, right? No, let's keep it until next week when there's no class. Yeah.
The next week, class.
1 year.
Yeah, we do have class.
Yeah. That's online. Right. Yep, we have class Friday. Yep. Right. What I was saying, right. So if I give it 2 points, right? The first thing that we can do is we can find the distance. We can find the distance between the 2 points. Anybody remember the formula? You do it in Form 1 or something. Distance between 2 points is what? It's square root of x2 minus x1 squared plus y2 minus y1 squared. Right? So if I ask you to find the length of this line or the distance between the 2 points, you can use this, right? So distance between 2 points is the same as length of a line, right? It's the same as length of a line. All right? For every single question, we will use these values here, right? Let's pretend this value is 4.2. And let's use this value here as 6.8. Okay? So we're using E as 4.2, which is also x1 and y1. And we're using B as 6.8, which is also x2 and y2. So I want you to plug in these little things here and find it, right? Tell me what you get. Use these values, right? And find the length of that line. Or the distance between A and 3. Use the values 4 and 2 and 6 and 8. Oh yeah, appreciate far behind again. Now start. I'm still join the line. Sure you said join the axis. Oh gosh. Now you don't need to graph paper, Charlie. We did that last week. Right? Use the formula and find the distance between the 2 points. What you can do? Huh? much? 2 root 10. So you end up with the square root of x2 minus x1. So that's 6 minus 4 squared plus y2 minus y1. 8 minus 2 squared. So I am getting the square root of 6 minus 4, 2 squared, and 8 minus 2, 6 squared. Right, since we did the surds and everything, I want you all to practice simplifying these things, right? 2 squared is 4, 4 plus 36 is 40. Right. Help me break down this, Christopher. Help me break down 40 in terms of surds. What would that be? So you always break down the 40 into a product, where one of them is a cubic square. So what you can choose? One of the values, one of the factors must be a perfect square. Carry 2. If I use 2 and 20, what you can use? Huh? What you can use? 6 and 2, you get 40. And what is factors of 40? So you use what? 4 and 10, yeah. You use 4 and 10. All right, online? You're using 4 and 10. So you'll get the square root of 4 by the square root of 10. Root 4 is 2. So if you went to the calculator and you put this in, the calculator will give you this. Right? But you have to remember how to do these things, right? Stefan? So you write 40 as 2 factors. One of them must be a perfect square. And then simplify it out. Okay? So that's the answer there. All get that? We're going to talk about it here. It's not you can do the same thing, then I give it a question. Right, so that's the length of a line or distance between 2 points. Any questions online? You gotta remember to do this. Anya, Javi, you gotta remember to do this. To write 40 in surds, right? Okay, so then you have it to doing that. So that's the first thing we can do. The first thing we can do is find the distance between 2 points. Where we can find all that? Gradient. What else? I'll leave in gradient for after. What else we can do? Right, not yet. Midpoint. We could find midpoint. The next thing we could do is to find the midpoint. Right? So what's the formula for the midpoint? Right? Add up the 2x values. Add up the 2x values, divide by 2. Then add up the 2y values and divide by 2. Go ahead. Use that same example and find the midpoint. So everything we'll be using those values as the example. So you know, following? What you all got? So you all got into this example. Midpoint AB are 6 plus 4 over 2 and 8 plus 2 over 2. So that's what? 10 on 2 is 5, 5, 5? 5, 5? All right, nice. Easy, right? Good. Now we're going a little bit. Let's go to, huh? Oh yeah, I mean like X2 area. So what I was saying there before she interrupted, my gradient. Next thing is gradient. What does gradient mean? No, what does it mean? It means slope. So gradient means how a line is sloped. Okay? So I want you to remember something about 3 types of lines, right? I'll give you the formula just now. But you have a line that could look like this, a line that could look like this, or a line that could look like this. Or we have one more. How is a line can look? Straight up here. Right? So a line can look like A, B, C, or D. Right? This line has no slope. Right? So the symbol that we use for gradient is M. So a line like this has no slope and the gradient is 0. Right? A line like this has some slope. What type of slope is this? Huh? Positive. So we can say the gradient here is positive. What kind of slope is this? Negative. What kind of slope is this? That's all the slope in the world. Right? So the gradient there is infinity. Okay? So this is a line that has no slope. This is a line that has infinite slope. Okay? So you have 2 types. You have those types of slopes there, right? Right? And as you all said, gradient is y2 minus y1 over x2 minus x1. Quick question, what kind of slope is that? Positive slope. So work it out one time. Work it out one time. Let's do what you got. Huh? Online if you get confused anywhere, let me know, right? Yeah. This is not much. Yeah. You guys gotta know that. Yeah, I know all these things. Right? 5 marks too, yeah. Yeah. Right? What again? 8 minus 2 over 8 minus 2. 8 minus 2 over 6 minus 4. That's what, 3? Yeah, right. Two more quick rules that we need to remember. Parallel lines. Again, as I said, you have done this in maths as well, right? What we know about parallel lines. Parallel lines are perpendicular to each other. Very good. Very, very good. You know? Parallel lines are perpendicular to each other. No, I like it. I like that too. That's a nice joke. Right? Perpendicular lines. Parallel lines are perpendicular lines. Right. What we know about parallel lines, audience? You never touch it. In terms of gradient. In terms of gradient. They have the same gradient, right? So M1 is equal to M2. That's okay?
Yeah.
What about perpendicular lines, Nathan? Right, but in terms of gradient, because the topic we're doing is gradient. It's different. Right, negative reciprocal. So the product of their gradient is -1. All right. So when you multiply this by this, you'll get -1. Right? It's called right? It's called negative reciprocal. Right? It's called negative reciprocal. Right. So quick example, tell me what you get. Right? Same thing we're doing, right? I'm giving you two lines. And the gradient here is 4. So what's the gradient here? Huh? Sure? So the gradient here is 4. Easy.
It's not negative.
So if I give you a line here, right? And the line and this line is perpendicular to that. What you would say? Right. So this line is perpendicular to this line. So what's the gradient of this line? This one here. Vishish, what's the gradient of this line? Huh? -1. Come on, son of it. -4. Right. Here what you just do, right? All you have to do, if you use that formula there, you flip the value over and you change the sign. That's okay? What is call this again? Negative what? Reciprocal. Right? You just call this your negative. With all my markers. Right? This is called negative reciprocal. So you flip it over, change the sign. Wait, what? But I have the mics and we have the yeah. Oh, yeah, put together a question, don't I?
I will block it.
What?
Just somebody wants to go in. Yes, it was just like that.
That wasn't me, that was me on the accent. I was beginning. But I was talking to the one who what language I was talking. Right, next one. Next one here, Sterling, help me out here. Right, I give you the gradient here. The gradient here is minus 3 and 2. What's the gradient? M1 and M2. Always remember, flip the bar to change the signs. Am I correct, Nathan? Am I correct? He said the answer is 2/3. Is that correct? No? Sorry? What? What's that? M of a square. What do you see in a square?
That's not how square.
Right? So the value is 2/3, right? So what this is here? M1 is what? Nathan, M1 is what? Here is negative 3 and 2. We find negative reciprocal. These two lines parallel. So what's M1? 2/3. Okay, copy it down. Just some rules for you to remember. I know. Okay. Next part. Next part. I just revising. We will be going fast.
But you're basing it on.
Equation stuff. All right, so those are the things I need to remember about gradient, right? Gradient and your midpoint and so on. Any questions online, Anya? Serena, you're okay with this? So always remember, if you have the gradient, you want the perpendicular line, flip the value, change the sign. It's called negative reciprocal. Really easy. All right. Next thing you have to remember from Form 1 is equation of a line. Yeah, Form 1. That's Form 1 stuff. Next one, equation of a line. Right? So we need to get the equation of a line. How do we find the equation of a line? Well, the equation of a line is always of the form what? Right? So the general form is that it always looks like this. Y is equal to mx plus c. Every time you see something in that form, y is mx plus c, that's a line. M is your what again? M is your gradient. And the c is your y. So if I were to draw a line, like what we had earlier, a line should have a y-intercept and a gradient. Does every line have to have a y-intercept or gradient? Does every line have to have a y-intercept or gradient? So, okay, so let me rephrase it. Can I draw a line without a gradient? Can I draw a line without a y-intercept? Right? So I could draw it without a y-intercept, but it still has a y-intercept, right? And the y-intercept is 0. So I could draw a line like this, right? The y-intercept is 0 and it has a gradient. But can I draw a line without a gradient? Yeah. Same one I showed you all earlier. Right? That's a line. Right? Gradient there is 0. Okay, technically it's no gradient. Right? So these are lines, right? So once you see something looking like this, you know it's a line. But how do you actually find that? Here's what you need. Number one, we need a point on the line and the gradient of the line. Okay. Once you have a point on the line and the gradient, you're good to go. How do we find the y-intercept? We use y-intercept is y minus mx. All right, and I'll show you an example just to make sure you're not confused, right? Can I have back the original values? A was what? And B was 6A. So when we work this out, we got the gradient to be what? We got the gradient to be 3. That's okay. Wait, Jalen there. Just Jalen and so we pay attention, boy. Jalen. I'm gonna make it to know your camera. Jalen. We shan't pay attention, Jalen. Oh, he actually replied this time. Friday, you do reply.
It's Friday.
No, Friday, you're gonna be? Right. So we know the gradients. Dylan, you okay? You gonna phone out come further, huh? When you fucking up, when you fuck. Right. So watch here. So we know the gradient and we know the point on the line, right? Which point I should choose? Anyone, it doesn't matter. Right? It don't matter which point you choose because both points on the line. Okay. So I will use 4 and 2. So I'm gonna find C. Step 2. C is equal to y minus mx. So I'm choosing A, right? So y is 2, gradient is 3, and x is 4. So I'm using this to find C. Okay, so I just rearrange this and I'm using this equation here to find C. So I'll get 2 minus 12 is minus 10. Okay, and you're done. Your final answer is y is equal to mx, we have m already, plus C. That's the answer. We have m from here. We have x. We know what x is, y and x are the variables, and the y-intercept is minus 10. Okay? Really easy, right? I want to do nothing too hard today because I'm going to forget this by following. Never. Because the real thing that we have to do is something called circles. Right? But I'm going over all of this to make sure. Huh? Not circle tail, circle geometry. Right, just do my favor here. Tell me what's the equation of a line here. All right, take a look at number 2 and 3. Right, try number 2 and 3. Try number 2 and 3 and find the equation here, here, and here. Find the equation of each one of those. Right, so tell me what you got for the equation in number 2 and number 3. Number 3 and number 3. One of them easy, one of them hard. Help me out here, Rishi, since you're all behind. Tell me what's the equation of this line. Do tell him step one thing. Right, well, look at the equation of a line. Y is mx plus c, right? So what was the answer? No, sir, to the whole equation. Y is equal to? Nice. Finally, you're logging. Just take a little while to load it, but when you load, it's looking okay. Just take a little while to load. Right, we have some problems here now. I have 2 other lines. I want you to write the equation of the line, right? Online, or try something from us. All right, online. Try to see if we can figure out the equations of both lines. This one here, this one here. This one easy. This one kind of hard. Right? But see if you can come up with the equations of those lines. And message your answer. Anybody online? All online. Everybody. Write the equation of those 2 lines. Right. Online, I see anything. What's the equation of this line? Let's pick on somebody. Anya. Anya, what's the equation of this line here? Right here. Huh? Push up, Anaya. Anaya still figuring it out. So Anaya, tell me the first thing. What's the gradient of this line? What's the gradient of this line, Anaya? What's the gradient of this line? You sure? Nah. What's it again? Look back at your Newton gradient. Look back at your Newton gradient. No, look back at your Newton gradient, and I told you what the gradient of a horizontal lines. What's the gradient? Gradient is 0, right? So it's what? Y is equal to 0, x plus 3. Yeah. That's okay? So the answer is really what? 0 by x is 0. So the answer is y is equal to 3. Sorry, 4. Sorry, thanks. 4. That line is 4. So the gradient is 0 and the y-intercept is 4. Right? So the horizontal line is the vertical line. Yeah, same. If this line is y is 4, and we had a guess, what do you think this line will be? What is 3? That's right, 3. So you're partly correct. Huh?
Is he right?
What do you think so then? Right. So it'll be. So is gradient is infinity. So whenever the gradient is infinity, the equation is x is equal to 3. Okay, x is 3. Right? Here what this line saying. This line saying that every single point on this line, y is 4. This line saying every single point on this line, x is 3. That's why we call vertical line x is 3, horizontal lines y is 4. Okay. All right, so every time you see a vertical line, x is 3, horizontal line, y is 4. All right, let's go again. All right, Daniel, you follow now. And I keep saying the wrong thing, right? Right, so write this down, write this down. The equation of a horizontal line, the equation of a horizontal line is always, the equation of a horizontal line is always the equation of a horizontal line is always horizontal, right? This is horizontal, right? Y is equal to the point it passing through, right? So y is equal to the point it passing through. That's okay? It's always y is equal to the y value it is passing through. Y value. You can put y value in brackets. So you recognize that this line, all the points on this line, the y value is the same. Huh? Well, yeah, y is equal to the same one. Yeah. Right, but even if they don't show you that, even if they don't show you what you see, just take the y value and the point it passing through, the y value, and the equation is that. Right, a vertical line. Next one, a vertical line is always x is equal to. A vertical line is always x is equal to the. A vertical line is always the equation is always x is equal to the x value passes through. X is equal to the X value it passes through. Right, let me just make sure you understand that. Right. What's the equation of that line? Right, let's pick somebody online. Javi, what's the equation of this horizontal line? Arista? Arista, the next one is yours. Javi, what's the equation of this line here? Javi? That's true, Javi. Javi, are you there? Oh gosh, Javi. Javi said Y is 2, is that correct? What do you think, Stefan? Yeah, it's a horizontal line, right? So Y is equal to the Y value the point passes, the line passes through. So the answer is Y 2. That's okay? Arisa, your turn. What's the equation of this line here, Arisa? Serena, you can message as well in the meantime. You and Jadon, you can message. But we're really waiting on Arisa. Come on, Arisa. Arisa. Around Jadon, check it back, the vertical line. Arisa and Serena. We are waiting on you. Serena said, that's not equation, Serena. You're missing something. You're close to it. You going again, boys? We going again? Is it just one long set?
No, sir. No, sir, no, I did.
Arisa, you're close to it, Arisa. You're missing something. That's not an equation. Look back at the last one and read over the notes. Oh gosh. Correct, Arisa. See, you hear all you. But you can carry 5. Still any follow up? Right, so the answer is X is equal to 5, right? X is equal to the X value it passes through. The X value is 5, so the answer is X is equal to 5. 5. So if I give you 5, can you draw it up? No. But if I give it X is 5, can you draw it up? Okay. Is that equation? Right? Is an equation. Serena, if you follow? Yeah? Okay. Next one. This time I'm giving you some points, right? 4, 1. That point there is 4, 1. And this point here is 10, 6. Yeah. Use those values. Find the equation of this line. Find the equation of this line. Remember, you need gradients and And we don't pay for the try this here, please. Find the equation of that line. Right, we are about to get a little harder. I'm going to implement the hard maths now, right? Right, we still on form 1 mark.
And then
Yeah.
with the answer, if paragraphs and why equal to X. You'll get wrong.
I mean, I like it just right too.
But literally after. They just.
I'm gonna put that one there. If they ask for equation, you gotta get a my equation. Huh? You find the equation of that line. What do you need again, Nathan? What do you need to find the equation of a line? You need the gradient and the y-intercept, right? Hurry up. Finding out wait, no, taking a long. Well done. Right, so Vishesh, what do we need? What do we need to find the equation of a line? Huh? We need the gradient of y-intercept. So what you got for gradient? Vishesh, why looking at the man book? So use it and what the gradient, do it mentally fast. 6 minus 1 and 10 minus 4. That's 5/6. And how you get y-intercept? Y minus mx, right? So which point you using matters? It don't matter which point you're using, right? So y is 6, gradient is 516 and the y-intercept is 10. So I use 6 and 10. It don't matter if you use 4 and 1 or 6 and 10. How much is that? Try it again. Come quick. So you end up with y is 516x. Oh, just wait, we calculate fast now. Negative again? Well, you got 7 over 3. Negative? Negative 7 and 3. If you want, you can multiply everything out, right? For those who online, I see the camera sign blocking it, but it's 516x minus 7 and 3. Right, I think somebody sent that just now. That was Jalen. Wait, no, Jalen, something wrong there. Check back your value, right? Anybody else got his values online? Yes, Gabby, you got that? Anaya, you got those values there? All right, let's go again, right? So we're going into add math mode, so let's get a little warm there. Let's go into add math mode here.
Yeah, I guess somebody say anything people want to do.
So we're going from this easy thing into this kind of hard language here. Right? So we jump in straight into it one time. Take a little read. Take a little read here and we will listen to All right, so next one. So here we are, right? We have a line, right? Right? We have a line and they want us to get a gradient. But we have a problem there. What's the big problem? It's not in the form, eh? It's not in the form y is mx plus c. So what we need to do? Put it in the form y is mx plus c. Right? And do me a favor, make y the subject of the formula there. So then follow through. Right? So take number one and put it in the form. Right. Oh yeah, take it. Oh yeah. Take that equation, 3x plus 2y equal to 15. Put it in the form y is mx plus c. Put it in the form y is mx plus c. Right, help me out here. Put this in the form y is mx plus c for me, Megan. Oh yeah, give a minute again.
Yeah.
Oh yeah, take a minute. Pen, get some charge. Put it in the form y is mx plus c, and then read it all.
I just think about it.
That's not AI, that's
Yeah, you're charging me better.
not AI.
That's not anymore.
That's not AI. Get you? Get you? Where you go? Yeah. What's the gradient?
Fine.
Right, Megan, let's go. Put it in the form, Megan. Make y the subject of the formula. What the first thing to move? Because I mean, I'm just well.
You need to get minus one.
But why moving first? Why moving the first, the two first, Megan? So you don't think you should move it 3x first?
Yeah.
And what you'll get? Now what you can do? Yeah. All over 2.
Yeah.
So you can divide everything by 2 and make it look like this. 15 on 2 minus 3 on 2x. Right? And to write it more formally, write it y is equal to minus 3 on 2x plus 15 on 2. What is the gradient, Yasin? What's the gradient? Just 3 on 2? What's it good, Yasin?
Oh, minus.
Minus 3 on 2. And what's the y-intercept? 15 on 2. It didn't ask for it, but. Right. Now let's go to the hard part. Copy it down, read the next part, and tell me what you think we should do, Christopher. Well done. Right. Let's take a look at this, right? So here's what they said, Chris. They said another line segment JK is perpendicular to GH. So you have JK and it's perpendicular to GH. And it passes through 4, 1. Right? This is JK and this is GH. Right? They want to get the equation of JK. So, Chris, what do you need to find gradient? Right? So you find the negative reciprocal to get gradient, and you also need your what? To intercept. Can you tell me what the gradient is, Nathan? What's the gradient of JK? The question is just what? Just yeah. Yeah, Nathan. What's the gradient of GH? And then try to figure out what's the gradient of GK. What's the gradient of GH again? Right. So what will be the gradient of the perpendicular? Huh? Positive 2/3. Very good. Positive 2/3. And now go ahead and find the y-intercept. Be done. So then I get you. Okay. So in exams, you might see questions, okay, well, you wouldn't really get this because the circles you're really going to get. But how I say, remember that, right? Right, Serena message what I got for your angle for your length. Sorry, for equation, please. Finish. Oh yeah, please just see. Find the y-intercept. Excuse me, we might go to
On it. And at this one, it's not the center. It's not like.
Hey,
We lost Serena. So Serena, what's the gradient of GK? What's the gradient of GK, Serena? Serena, read the question, please. GK. Read the question. All right, but you don't need the speaker to read, right? Read the question and tell me what you get for the gradient of JK. Right, so the gradient JK is right here, that's 2/3. Right, and the y-intercept is y minus mx. And the y-intercept is, sorry, is c is y minus mx. Y is 1, m is 2/3, x is 4. Right, so that is 1 minus 8/3. Right, so that's what, 513? Or look at that, minus 513. Yeah, so the final answer is what? Y is equal to mx minus 513. Suppose I want to make it look nicer. What I can do, like I don't want the fraction, multiply everything by 3. So if I multiply everything by 3, I'll get 3y is 2x minus 5. Okay, so I will try to make it look a little bit nicer. Last thing, are we done? I want to give you one last thing. I know. Let's check it out. That's not. That's what I like. That's what I like. I did check. Right, take a small note, take a small note. Here's something important that I really need to know, right? When we solve two equations simultaneously, we are actually finding their point of intersection. We are actually finding their point of intersection. We are actually finding their points of intersection. Okay, so watch this here. Let's say I gave you two lines. I gave you line 1 and line 2, right? Right, Nathan? And I said to find the point of intersection. So I want that pointed. I want you to find the point of intersection. What you have to do is you have to solve them simultaneously. That's okay? In add maths, most of the time they use substitution method. Okay? So do me a favor, solve those two simultaneously. Any method you want. You could use elimination if you want. But I want you to solve these two simultaneously, please. Huh? Yasin? We don't understand Yasin? How to solve simultaneously? All right, so you'll see what and I'll show you how. While everybody else will it out. Shall we have my phone? I mean, I have my phone and oh yeah, solve simultaneously. Got my sign. Solve that fast amount. Any method you want. Right, solve it simultaneously. Sabina, you have to do that. Anaya. So any method you want, solve simultaneously. Use elimination if you want. Right, but ideally, I'd like if you could substitute this and this and solve. Substitute, solve. Oh yeah, take your time and solve this one up online. Once you get it, solve then you answer, okay? Because then you answer. X and Y, right? Yeah. Very. So when we go, come on, we go, you have to learn something, you know. Let's learn something quite good aside from that. Remember for the sign, right? Those are the different signs. What's what I on BC, hurry up. All right, so time up. So basically, I am going to use this here and I am going to substitute for Y right here. Y is this, so I'm going to replace this Y with that. So I'll get 2 by 4x plus 3 is minus 6x plus 8. Right, so again, the habit of using substitution one time, it doesn't add mass, right? So this is 8x plus 6 is equal to minus 6x plus 8. Move across the 6x. Move across the 6, so I'll get 8 minus 6. So I'll get 14x is equal to 2. X is equal to 2 over 14 or 1/7. Positive, right? Right, so x is 1/7, so I'm coming right here. And I'll get 4 by 1/7 plus 3, which is 4 and 7 plus 3. It's up to you. You can put 21 plus 4, 25 on 7. So your answer is 1 on 7, 25 on 7. Anybody get that? Right? Right, now to go over those things, right? All right, so